behavior rules that you need to know. And I always tell students, if you don't have to memorize something, kind of tack it onto knowledge that you should already have. So for example, we already know that a quadratic like y equals 4x squared, how is that going to look? That's going to be a concave up parabola, right? So I can already look at this leading coefficient and know that it's concave up, and I can look at the x squared and know that it's a parabola shape. What about something like negative 7x? That's a linear equation this time, and it has a negative slope. So I know it looks like this. So already I can start making generalizations about even degree functions and odd degree functions, the way their ends of the graph go, and the job of the leading coefficient, and if they go up or down. So a lot of the end behavior you could tack on to just quadratics and linear functions, and then just expand as you go up in degree. So the rule is when your leading coefficient is positive, like 4x squared, the right side of the graph always goes up. And when the leading coefficient is negative, like negative 7x, the right side of the graph goes down. And what they mean by right side of the graph, they mean the literal right hand of the graph. Is that pointing up or pointing down? So your first step is put it in standard form, look at the leading coefficient, and decide what the right side does. So you have to do this first. Then the degree is going to tell you if your arms need to go in the same direction or if they need to go in opposite directions. So if the degree is even, like x squared x to the fourth, the left side is going to go the same direction, like a parabola. Both go up or both go down. And if the degree is odd, the left side goes the opposite direction. So I think of odd and opposite, they both start with the letter O. So linear, cubic, like a cubic function, one side goes up and one side goes down. So you already, by looking at the equation, can determine the end behavior. So if we look at number one, you always want to scan first that it's in standard form, and you want to look, did the person who wrote this test or question ask you for the right end first? Because sometimes I might just flip-flop the order of these, but you should always do the right end first, because that's your leading coefficient. And if there's no number in front of that first term, the number is positive 1. So the right end of this graph has to go up. And then I look at the degree of this function, which is the highest power. In this case, it's 5. That's an odd number. So if right is going up, then left has to go opposite, and left is going to go down. So when I start sketching this graph, I already know what the ends of the graph do, and then I can put that together with my zeros and multiplicity and y-intercept, and I can get a pretty good idea of what the function looks like. So could you go through number 2 and 3, and then I'll just explain this notation at the bottom, because you might not know what that means. But if you could just take a look, make sure it's in standard form, answer the right and left end, kind of your quick check for understanding. So in number 2, it is already in standard form. The right end is going to go down, right? Negative 2 is going to make the right side go down. And then I look at the degree is odd, so down and up. It has to go opposite. And then in number 3, the leading coefficient was positive 1, so the right side of the graph goes up. 10 is an even number, so it'd be up, up. And my Google Docs, I guess, got kind of screwed up when I put Word doc into Google Docs and I didn't realize it. But another way to describe end behavior is using limit notation. We're going to study limits at the end of the course, but it's never too early to start planting the seed on what this notation means. So in number 1, it's referring to up here, and it says as x goes to infinity. So instead of saying the right end of the graph, they're just saying as x goes to infinity. It means the same thing. It's just a little bit more sophisticated in mathematical symbols. Right end, x going to infinity, our function went up. So our function is going to go up towards positive infinity. So instead of right or left, we're using infinity or negative infinity for x. And instead of up or down, we're using positive infinity or negative infinity for y. So see this line right here? Like this line came from over here. And like this right here actually came from over here. As x goes to negative infinity, f of x goes to where? So I just kind of screwed that up. But so when I'm still talking about number one, as x goes to negative infinity, that's the left side of the graph, right? X is shooting off to the left. What's my function doing? Based on this rule, our function, our y values are going down. So they're going towards negative infinity. So just using kind of the four quadrants of your graph, or the four, I guess, axes, this is x going to the right. So this is x going to positive infinity. This is x going to the left. So x is going to negative infinity. This is f of x going up, right, towards positive infinity. This is f of x, or your y values, going down. We're just using negative infinity. And I think that sometimes on the SAT, this could be an easy question if it was phrased like this. And then if they just change the language, you have no idea what they're talking about, but you know how to answer the question. So I wanted to just show it to you both ways in case they use infinity on the SAT, but I'm not sure if they will or not. So in number two, just before we kind of pause this for now, as x goes to the right, the function went down. As x went to the left, the function went up, just bringing it from up here, right? And then this last one was up, up. So those should both be positive infinities. All right, so I gotta